Now that we have our R, let's write our DEP and see if we're getting anywhere here. Let's see, it was EA times DA over, we said big R. Made that approximation the easy way, we just wrote it down, equal times E to the J omega T minus K little r. So now here is where we want to plug in what we just calculated. It's big R times 1 minus xx plus y over r squared. Minus kr, that's all correct, yes. Close the parentheses there. Yes, that is right. Okay, so now we can start taking it apart. Let's see, we might want to say it's E A dA over r, e to the j omega t, and you can see we can still pull a kr out, and now it's the big constant r. So now we have omega t times k big R, the approximation we would like to have done before, but it would have made it trivial, but we still have remaining an e to the j, and then that's plus k, and then this r cancels one of those r squareds, xx plus y over r. And that's what's left. And that is DEP. Okay? So now, all we got to do is integrate. We're ready to find EP. It is the integral of all those little DEPs from each Haughton's wavelet. dA is going to become xy, or dx dy. All this other stuff is constant. E a over r, e to the j, omega t minus kr. Integral, two integrals, right? We got to integrate with respect to x and y, of e to the j k xx plus y. In fact, actually, we'll go ahead and separate those out. We don't want those together. They'll just cause trouble. Those are troublemakers. We got one e to the j k xx over r. And since it's plus, so just the product of the two, e to the j k y over r. And then dx dy. And we put on the limits. Here's our aperture. Let's see, the x-axis was a. This is the origin, so it's minus a over 2 to a over 2, and it's minus b over 2 to b over 2. So minus a over 2 to a over 2 minus b over 2 to b over 2. So it's really two separate integrals. You can actually pull the b and the dy in this integral here, and it's this integral times the x integral. You don't really have to have them inside of each other. So let's do that. Let's see, EP, see how far we get, is EA over r, the dA is gone, e to the j omega t minus kr. And then let's do the x integral first. That's going to be 1 over jk big X over r, 1 over jk x over r, and then e to the jk xx over r, e to the jk xx over r, evaluated from minus a over 2 to b over 2. And now, have I left myself room for the second integral? Ooh, I don't know, it's going to be close. 1 over jk big Y over r, e to the jk big Y little y over r, evaluated, oh, plenty of room. From minus b over 2 to b over 2. It's not really easy to read, but you get the idea. I said it. Let's keep going. E, P, like go till we run out of board. E, A over r, e to the j, omega t minus k, r. And now we have to apply the limits. Let's see. we've got, let's say 1 over j k x over r, big X over r. And then let's say this is, that was an A. E to the, now we're going to plug in A, or A into that X. And it's really not going to do anything for us. It's going to become E to the J K X A over 2R, it's the half, minus E to the minus J K X A over 2R. And then this is going to come 1 over J K Y over R. And we're going to get E, oh, we're running out of room again, E to the J K Y B over 2R minus E to the minus J K Y B over 2R. Barely fit. Let's see, should we throw in the towel on this board? No, let's not yet. Let's go ahead and let's throw in the towel on this board. Start in a minute on the next board.